Alright, this is section 3.6, video 2. And we're going to use the 3 steps in differentiating an implicit, using the 3 steps to find dy over dx by implicit differentiation on the next example. So, we need to find, for the function y to the 4th plus x to the 4th minus 2x squared y squared equal to 9, we need to find dy over dx and then take that function and evaluate it when x is equal to 2 and y is equal to 1. So first step, we need to find dy over dx. So we're going to take each individual part and differentiate it. So the first one, y to the 4th, would give us 4y cubed, and I have to tack on the dy over dx. On the second one, x to the 4th, would become 4x cubed, and then I have to use the product rule on the third term. So the first part of the product rule would give me 4xy squared, plus the second part would give me 2x squared times 2y dy over dx. And all of that would be equal to 0 because the derivative of 9 is 0. So we're going to simplify just a little bit, clean it up. I have 4y cubed dy over dx plus 4x cubed minus 4xy squared plus 4x squared y dy over dx. That's the first step. All that equal to 0. That's the first step. Find the derivative. The second step is to group all the dy over dx's on one side and everything else on the other. Okay, so I'm going to group all my dy over dx's on the left-hand side of the equation and put everything else on the right-hand side of the equation. Truly doesn't matter which way you go. This is just my preference. So I'm going to have 4y cubed dy over dx plus 4x squared y dy over dx, and that's going to be equal to 4xy squared minus 4x cubed. Alright? Now, that next step tells us to factor out the dy over dx and then divide by what's left over. So if I factor it out, I've got dy over dx equal to, or not equal to, times 4y cubed plus 4x squared y. All of that is equal to our 4x squared, our 4xy squared minus 4x cubed. Then we divide by the parentheses, giving us dy over dx equal to 4xy squared minus 4x cubed over 4y cubed plus 4x squared y. Now at this point, if you can simplify the problem at all, go ahead and simplify it. I can take a 4 out of everything. So we're left with xy squared minus x cubed all over y cubed plus, y cubed plus 4x squared y. Nope, I need that y gone, sorry. Come on. Plus x squared y. Alright, so we're just taking the derivative, or simplifying as far as we can. Let's see. And I have a mistake that I just caught. Go all the way back when we're taking that derivative. This should be minus 2. So I've got a minus here that I'm missing all the way through the problem. Sorry about that. This is why we always go back and check our work. This is very easy to leave off negatives. So the real answer is y cubed minus x squared y on the bottom. Sorry about that. All right, now, what we need to do at this point is evaluate. So part B would be to evaluate when x is equal to 2 and y is equal to 1. So we're just going to plug that in. So our dy over dx becomes 2 times 1 squared minus 2 cubed over 1 cubed minus 2 squared times 1. All right, when we plug all this in, the top becomes -6, the bottom is -3, which simplifies down to 2. So, two things. The advantage to simplifying up in the top part, where we simplified right here, that gave us an easier problem to deal with in part B. Okay, but also, you always want to simplify because that's the most precise answer. All right, that's it. So let's look at the next slide. So notice that in the example above, the given point is on the curve. Since x equal to 2 and y equal to 1 satisfy that original equation. If you plug all of that in, 1 to the 4th plus 2 to the 4th minus 2 times 2 squared times 1 does give us 9. So in economics, a demand equation is the relationship between the price of an item and the quantity X that consumers will demand at that price. All right? So for this, when we're dealing with a demand equation, we're going to have problems where it's going to be easier to use implicit differentiation to solve the problems than using another option. So let's look at example 5. Come on. There we go. So for the demand equation, x equals the square root of 1900 minus p cubed. We want to use implicit differentiation to find the derivative dp over dx, then evaluate it at p equal to 10 to interpret our answer. So we have the function x equals, let me get a different color. X equals the square root of 1900 minus p cubed. And we can use this formula right here if we wanted to and do the chain rule and all that fun stuff. But we don't have to. If we take a second and square both sides, then we have the function x squared equals 1900 minus p cubed, which would be much easier and much faster to find the derivative. So when we find the derivative using implicit differentiation, I'm going to have 2x. The derivative of x squared is 2x. The derivative of 1900 is 0, so I get to ignore that. And then minus 3p squared dp over dx. Again, we're differentiating with respect to x, and p is a different variable. All right, so we've differentiated. Now we need to find dp over dx. So I'm going to divide both sides by negative 3p squared, which would give me dp over dx equals to 2x over negative 3p squared. And we wouldn't leave the negative in the bottom. Okay, that's bad form. So make sure to either float it out to the front or stick it up in the top. So our differentiation gives us negative 2x over 3p squared. And now we want to evaluate that at p equal to 10. So when p equals 10, we need to have an x value. So the first thing that we need to do is find x. And if we put p into the original function, x is the square root of 1900, minus 10 cubed, which would give us the square root of 900, which is 30. So when P is equal to 10, X is equal to 30 on that curve. So now we can find the derivative of P with respect to X. So I have 2 times 30, or negative 2 times 30, sorry, over 3 times 10 squared, giving us negative 60 over 300, which is equal to negative 0.2. So the interpretation here, this says that the rate of change of price with respect to quantity, so rate of change with respect to quantity is negative 0.2, or that increasing the quantity by 1 decreases the price by 0.20. So increasing the quantity by 1 will decrease the price by 0.20, or 20 cents. All right? So therefore, each 20-cent price decrease will bring approximately one more cell at this given value. All right?